In the existing video for 7.6, she takes you through an example for finding the center of a mass, but she used geometric shapes, so she just used rectangles instead. And most of the time that's just not going to be the case. You're going to have curves because obviously this is a calculus course, so we're going to be using integration as opposed to just finding areas of rectangles. So I wanted to kind of take you through the formulas again. So she did take you through the formulas in that video, but I want you to understand what that looks like when you're looking at a picture like this. So this is just some random f of x, g of x. So I'm dealing with the center of a mass of a planar lamina, and keep in mind that while in the video she actually found a representative rectangle, which was a rectangle, here I have smooth curves. So what I'm going to be doing is looking at if I were to draw in the rectangles. So think back to Calculus 1 when we first learned area and we said, hey, let's draw some rectangles and let's find it when n is 5 or when n is 10 or when n is 100. And eventually we said, hey, let's let n, the number of rectangles, be infinite. And that's where we talked about limits and things like that. So that's what we're doing here, is we are essentially going to integrate when the number of little representative rectangles approaches infinity. So let's take a look at how we can compute this or let it make sense to us so we're not just remembering a formula. So just as we did before, we have mass is equal to density times area. Now the density for the center of mass of a planar lamina is typically considered rho. So it's a lowercase p, and it's a little bit curvier than that, but I suck at writing them. So just know that that's the Greek letter rho. Rho is the density. And so I want you to understand that when you're finding the mass of something like this that's not a rectangle, you're actually going to have rho in your answer. So don't be concerned about it. You don't have to ever find rho. You're just going to have that as part of your solution, knowing that you would take that number, multiply it by rho, and that would be the actual mass. So multiply it by whatever the density is, which we don't know. What we can do is find the area. So again, in our last example in the video, she made that very easy. She just said, hey, look, there's some rectangles. Let's take length times width. But you know, you're in calculus too, and you should be able to find the area of a curved figure as well. So keep in mind that the area is obviously just height times width, just like you did with the regular rectangles. The height of our figure here is always going to be f of x minus g of x. So think of it this way. I've got f of x here and I've got g of x here. That makes sense that that would be the height of each representative rectangle. So keep in mind that's for each rectangle. So this height is f of x minus g of x. The width is just however wide I'm making my representative rectangle, which, as we know when we start integrating, is going to just become dx, which is perfect. So again, turning this into an integral from a to b, which sometimes they'll give you those values, but typically you're going to have to find the points of intersection. This is how I would find the mass. I'm going to take rho, which is just a constant, so notice I've taken it outside of the integral, and then I'm integrating from a to b of f of x minus g of x dx, which is all of this, the area. Just as she did in the video then, the moment is mass, which is what we just found here, times distance. So notice I've just written this part in green again because that's just the part from right here, which is how we found the mass. And then all really we're doing is finding the distance. So if it's the moment of x, then the distance is averaging f of x and g of x for each of those x values. So that's all this is I'm taking f of x plus g of x and I'm averaging it, because that would give me that whatever that center point would be. So this would be that would be of the y value. I did that wrong. That would be f of x, which is the y value, plus g of x divided by 2. So we're just averaging. And then the only difference down here for a moment of y would of course be, what's this value? Well, this value is just whatever the x value is. So that's where all of that comes from. So don't just try to memorize what these formulas are, but try to understand what we're doing here. The center of mass then, just as she went through in the last video, is then taking those moments, and it looks like I possibly did that backwards. No, I did it right. I'm taking those moments and dividing it by the mass. So this would be the moment of y divided by the mass, and this would be the moment of x divided by the mass. So that's the formulas that we're going to use, and I'm going to take you through an example where we're using these formulas. So looking at this example together, obviously I've written most of your formulas there at the top, and we're trying to find the center of mass, and I did not write that formula, but we're finding just x bar, y bar, which, as we know from statistics, means we're finding an average. So that's all I'm doing, is I'm finding an average x and an average y, and that is found by taking the moment of y divided by the mass and the moment of x divided by the mass. So that's what we're going to work on together. Now, I've already drawn the picture of f of x equals 4 minus x squared, which obviously is a parabola turned upside down. And remember, I'm looking for the center of mass. So just eyeballing this, I know it's going to be at 0, and it's going to be close to 2. Now, it's probably not going to be quite to 2, because if you'll notice, down here is a lot fatter than up here. So my guess is we're finding a point somewhere in here. But let's do the math to figure it out. So again, we're going to start by finding the mass. And the mass is rho, and remember, rho is that uniform density. That's just what we're using for density. And oops, not from A to B. From A to B, in this case, I'm looking at from -2 to +2. So from -2 to +2 of, and then I'm looking for f of x minus g of x. So in our last example, we actually had two lines that each had their own equation, if you will. This guy is obviously 4 minus x squared. Well, g of x would be this line right here, which of course is y equals 0. So I'm subtracting 0. So you won't see that, but that's what's happening. So I'm going to take 4 minus x squared, and then it would be minus 0 dx. So that's how we're going to find the mass. So if I am integrating that, I'm going to again keep rho on the outside, and as I said on our last slide, rho will be part of your solution, and that's just fine. If I integrate 4, I get 4x, and if I integrate x squared, I get x cubed over 3, and I'm integrating from -2 to 2. So that is going to give me 4 times -2. I'm just going to go on the next line because I know I'm going to run out of room. So 4 times 2, which is 8, minus x to the third, so that's 2 to the third, which is 8 thirds. And then I'm subtracting -2, so I'm doing 4 times -2, -8, minus -2 to the third is -8 over 3. And then, of course, if I distribute this minus sign, I end up with some positives here. So I end up with 8 and 8, which is 16. And I end up with -8 thirds and -8 thirds, which is -16 thirds. And again, I encourage you to actually work your brain muscles a little bit. Don't just plug this into your calculator unless, of course, you're checking your work. But if I were to try to subtract this myself, it's okay to say, well, 16 is 48 thirds minus 16 thirds, which is 32 thirds. So work those brain muscles, use your mental math. Oops, don't forget, like I did, that we have a rho out front, so this should be rho times all of that. Well, let me erase that equal sign. There we go. And then a rho out here, and then row. So 32 thirds row is my mass. Now, we already talked about x bar. We know that this line is the axis of symmetry, and that is, of course, the line x equals 0. And I know that everything on the left side of the axis of symmetry matches with everything on the right side of the axis of symmetry, and so I don't actually have to find x bar because that's what x bar is going to be. So without any work at all, x bar is going to be 0. Now, obviously, you're not normally going to get that, but you'll get the idea, and you'll be able to work through an x bar equation on your own. Now, in order to find y bar, what do I have to do? I have to look at this, nope, wrong one. I have to look at this formula, because remember, y bar is the moment of x divided by m, and we already found m, which is our mass, 32 thirds row. So to find the moment of x, I'm going to take row, integrated not from a to b, from -2 to 2, and then I'm going to have f of x plus g of x divided by 2. Now, of course, f of x is 4 minus x squared, and g of x, remember, was 0, so all divided by 2, and then, I'm sorry, plus 0, and then f of x minus g of x dx, which, just as we did before, is 4x, sorry, not 4x, 4 minus x squared dx. And again, I could put the minus 0, but you get the idea. So I'm going to go ahead and move this 2 to the outside, because who needs fractions in their life? So this is row over 2, integrated from -2 to 2. I have, doing some distributive property there and foiling, 16 minus 8x squared plus x to the 4th dx. And if I continue, oops, I forgot my over 2, so row over 2, and I'm going to have 16x minus 8x cubed over 3 plus x to the 5th over 5 from -2 to 2, and this one I am going to just cheat a little bit, so this video is a little bit shorter. If you do all of that math, you end up with 256 row over 15. So I already know that y bar is 2. I need to now find, I'm sorry, that x bar is 2, so I need to find y bar. I think I used a different blue, and that's just going to bother me. Yep, I'm that person. So y bar, oh, I just got done teaching linear algebra, and so I'm using vectors instead. It's bar. Y bar is equal to, again, the moment of x divided by m, which is our mass. So I have 256 row over 15 over 32 row over 3. And if I do some simplification there, I end up with 8/5, and obviously those rows canceled, and then the rest of it I just, did the math. So I end up with 8/5. So remember that my solution, the center of mass, is an ordered pair, and my ordered pair then is x bar y bar, which is 0, 8/5. Now if we go back to our picture where we started, we said it should be somewhere in here, and if you'll notice, 8/5 would really be somewhere in there. So 0, 8/5 looks pretty good for that guess that we had at the beginning. And remember, what we have found is the center of mass, and the center of mass means if I took that figure and I turned it sort of horizontally, I could put my pencil right there, or my finger right there, and that would balance. It's the center of the mass, so it would balance perfectly at that point.